Okay, lecture 28, the nomenclature of aldehydes and ketones. Because they're so closely linked, they're so similar, we take this one chapter where we put both of these types of molecules together when we're naming and showing the structures, etc. So let's start the naming. We have butanal. That Al tells us that the end of this compound is going to have this structure. So it's butanal, 1, 2, 3, 4. And you can leave it like this, but it's very often you put the hydrogen there just so that there's no chance for a mistake. And then this carbon of the aldehyde group is carbon number 1, always will be. So this is 3, and then we have 3,3-dimethyl. So even though it's a trickier functional group than we've seen, it makes the naming or the drawing of it easier, and the naming too, going the other way, because this has to be carbon 1. All right, so we have a carbon here, 2, 3, 4, 5, 6. So this is going to be hexanal. And no need to put a 1 for the functional group. This is carbon 1. So because we can't extend the chain with that hydrogen, we know when we have the Al, that tells us this group is on the end. Then we have 2, 3. This is an ethyl group, methyl, chloro. So actually I got to put it down here. Make sure I'm on. So 5 chloro, 3 ethyl, 4 methyl, hexanal. Make sure 1, 2, 3 ethyl, 4, yep, and then chloro. So now moving fast, because it's the same naming as we've had before. We just have these new functional groups, but all the substituents are numbered in the same way. Here we have heptanone. So 1, 2, 3, 4, 5, 6, 7. Hepta, so that's 7 carbons. This 3, 1, 2, 3, that O-N-E, that one, indicates that it is a ketone. And then once we've numbered that, then everything else falls into place. So 1, 2, 3, 4 bromo, 5, 5-dimethyl, and we're done. For this one, we have 1, 2, I'm just going to, you don't have to do this yourself, but I almost always do this one. It looks pretty complicated just so I can pick out that longest chain, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have nonane. And it's going to become nonanone. And then where do we, from 1, 2, 3, 1, 2, here's where we pick up the first substituent. So we have 2 chloro, 3 chloro. Okay, so now as opposed to the aldehydes, where the aldehyde group has to be on the end, the ketone group can be, the carbonyl group can be anywhere along the chain except on the end. If it's on the end, then it's an aldehyde. So really, aldehydes and ketones are very, very similar. The aldehydes, though, have to be on the end. The ketones, that C double bonded to O, can be anywhere throughout the chain. So we have, this is an ethyl group, chloro, so 2, 3, 6. So 2, 3, 6 trichloro. Then we have an ethyl group here and then here, so 4, 7 diethyl. And then we have to put in, because it's a ketone, we have to put in where that C double bonded to O is, nonanone. And then benzaldehyde, I just put it in there because it's we can't have the aldehyde as part of the chain because that hydrogen would prevent us closing the chain, but it can certainly be on the outside. So that's benzaldehyde. It's a benzene with an aldehyde group on there. And then if we had to do some further naming here, it ended in benzaldehyde, but this is going to be site number 1, 2, 3. So this would be 2 bromo, 3 methyl. Should be very, very similar to, or very, very familiar to you. And this actually, because we've named cycloalkanes, we've named different other rings, including benzene, benzaldehyde, that all have 2 bromo, To interrupt myself here, but just want to make sure everything's good. So we have the basic idea of how to name these cyclic structures. 3-fluorocyclohexanone. So 1, 2. So this is cyclohexane with a ketone group, and that's going to be site number 1, 2, 3. That's fluoro. And then this thing, 1, 2, 3, 4, 5, 6, 7, 8. Oh, it is 8. It didn't look like 8. So this is number 1. So we'd number it in this direction. And then we'd have, so chloro, yeah, so it'd be 5 chloro, 2, 3, 3 trimethyl, cyclooctanone. And that is the deal.